Hello, yesterday we finished off with this slide. We were talking about similar polygons, or two polygons where the corresponding angles are congruent and the corresponding sides are proportional. Now, if we said these two quadrilaterals are similar, we want to find the values for x and y and z. Well, 12 is going to be is going to correspond with 5 in our smaller quadrilateral. So we could set up the proportion 12 over 5 is equal to 15 and y correspond. So we could say 15 over y. So now what we can do is cross multiply and divide. So take 5 times 15, which is 75. So we have 75 is equal to 12y. So now when we divide by 12, 75 over 12 is 6.25. So that is going to be our value for y. Now if I want to find my value for x, what I'd have to do, I could take the same thing, 12 over 5, because those still correspond, but now this is equal to x over 3. Now when I multiply, 3 times 12 is 36, and that's equal to 5x. Divide by 5 on both sides, and our value is going to be 7.2. Now, z, we'd have 9 over z because those correspond, so 12 over 5 again is going to be 9 over z. Cross multiply and you'd have 45 equals 12z. Divide by 12, 45 over 12 is 3.75. So that's how we find our missing parts in similar triangles. Now if we wanted to see if these figures are similar, what we would do is we would see if 8.51 over 2.3 is going to be equal to 11.1 over its match of 3. Is this equal to 7.4 over 2? Is that equal to 9.25 over 2.5? And is that equal to 6.29 over 1.7? So we'd want to divide out all of these, and each one, this equals 3.7, this one equals 3.7. All of these are going to equal 3.7. And when we see here is that these figures are going to be similar. Now, a dilation is something that creates similar polygons. So if I want to make a dilation here with a scale factor of 3/4, what I do is I pick any point. First I'll pick point B, and this is going to be the point I'm going to be dilating from. And I'm going to go to each of my endpoints, 1 through C, 1 through A, and I am going to measure along that distance. So I'm going to take out my measuring tool, have a ruler. Now this ruler is actually really tough to measure with, so we'll see if I can figure it out. What makes it tough is it doesn't line up evenly here, but let's say that this is like 12.2. So if this whole distance is 12.2, what I'm going to do is I'm going to multiply 12.2 times 0.75 to get 9.15. So I'm going to go to 9, and between 9.1 and 9.2, I'm going to make a dot. So this point right here is my, is going to be C prime, because I moved it back using the scale factor 3/4. So now if I do my other side, it's going to be pretty close to this. I'm not going to piddly around to make it perfect, but let's say that's 6.5. So if the whole thing is 6.5, I'll do 6.5 times 3/4 to get 4.87. So 4.87 will be right around here. So now I can move this away. I have my point here, which is now my A prime. And my new triangle, oops, I wanted a different, let's just make it big and red. This is going to be my new triangle, which is a similar triangle to the bigger triangle, because dilations make similar triangles, um, but it's 3/4 the size. All right, so now they tell us to measure each side of the polygon and dilate with a scale factor of 3/2. Now this is a little bit different. We can choose any point. I'm going to choose A, and I'm going to use a scale factor of 3/2, which is 1.5. Oops, that's not what I want. I'm going to pick my dotted line again, and I'm going to have my dotted line go through each of the endpoints, like so. And now I'm going to take my trusty ruler out. Maybe I should say my meddlesome ruler. And I'm going to measure from here to here is 3.5. So I take 3.5 and multiply by my scale factor of 1.5, and I get 5.25, which should be somewhere right there. Now I'm going to do that to each of these segments. So I'm going to take this, put it back on there. Oh, that's close enough. So this is 5.4. So I'm going to take 5.4 times 1.5, and I get 8.1. So I'm going to go to 8.1 and make a dot. And now I'm going to slide this down here and measure out to 7, or maybe 6.9 times 1.5. That's 10.35. And then my last side is 7, so 7 times 1.5 is 10.5. So I'm going to make a dot down here. So now, if I want to see my dilation, we just have to connect all of those points, and each length on my big similar shape should be 1.5 times the smaller length. All right, now we have one more problem before the end of the lesson, and it's a similarity problem where we need to find BE and BA. Now this problem, it's a little unclear if E matches up with C or if E matches up with B. So what we do is we use the similarity statement that's given in the problem. EB is the first two letters, which will match up with CD. That will be equal to BA over DB, which will be equal to EA over CB. Now, once I have the similarity statement written, now I'll just fill in the values that I know. I know EB, or actually I don't know EB, so I'll just leave EB. But I know CD is 3. BA, I don't know. And that's over DB, which is 2.5. And then finally EA, which is 20, is over CB, which is 4. So now I could just look at this side of the equation and do 20 times 2.5 and then divide that by 4. So I know BA is equal to 12.5. If I wanted to solve for EB, I would set EB over 3 is equal to 20 over 4. Multiply, that's going to be 60 over 4, which should equal 15. So that's how we find our values for BA and EB. All right, hopefully that helps you get through the rest of your assignment. This actually should say 11 since you did 1 through 10 yesterday. So 11 through 16. Good luck.